So good morning, all of you.
Good
Good
morning,
morning, sir.
Good morning, sir.
Good evening.
So I think there might be some new additions to the class. If people are new, uh, I think somebody is trying to upload maximum all the videos in the YouTube. You can get the links from them from your classmates. Who is dealing that? I forget the name. Somebody is dealing with this.
It's me, sir.
Okay. Chanakesha. Fine. So, can you post to the new people so that they can use the videos that are in the
Yes,
past?
sir. I already shared the link to in the WhatsApp.
Okay. Thank you.
Okay, sir.
Right. So up to now we have been discussing about an array, right? In that we have also tried to search for some element like binary search. So I think most of you might have understood based on the last explanation. I think we have also done it using Agarwal's computer, her Raptor tool. Okay. So slowly, one by one, we have conquered. So now we know how to sort an array, and also we know how to. Did we discuss about sorting the array in what we say, Raptor? I think we have discussed it, right? I have even drawn the flowchart, right?
Yes, sir.
Yes.
Right. So I think we know now how to sort something in an array. So for your practice, you take few other numbers, increase the array size, and see how it is working by observing it, so that you will get some practice. Okay. So now let me talk about something like if you think about sorting, there will be no much practice in problems, right? You might have observed that sorting is a technique where you need to either put it in an ascending order or descending order. So I think it's your time to take different numbers and try to sort it. In one way, you try to sort 1, 2, 3, 4, 5 numbers, okay, which are already sorted. You try to sort and see what will happen. If any number changes, then your algorithm is wrong. And also try to sort 5, 4, 3, 2, 1. This is the worst case. In this, we call this 1, 2, 3, 4, 5. What we write 1, 2, 3, 4, 5 as best, input. So, or we can also say best case. If you write 5, 4, 3, 2, 1, it is actually the worst case. So in these scenarios, your algorithm working is very important in terms of time complexity, which you will get in your other courses like data structures. So we think about an average case in which you have 1, 2, 3, 5, 4 something, or you might be having 1, 3, 2, 4, 5. So you will think that this might be an average case because only few numbers are being sorted here. Okay, so when you consider this one like sorting, you should take all this type of cases and test your algorithm. Okay, every time you take one number and try to sort it on paper first. So work it out on paper manually with your pen or pencil. Then try to give the input to already written flowchart or write it on your own again. If somebody has copied it from what I have told, you blindly put it aside and try to do it from the scratch. So try to write the algorithm from the scratch, and from the algorithm you try to write down the flowchart in the Raptor tool. And for pseudocode, I want to tell you one hint. Like if you start something like you might be having three functions. One is main, right? The other one might be some other function where you are using some swapping. Okay, swapping function, and maybe swapping is a subchart. What is the other function we are using here for this? Are we using any subcharts or functions in sorting?
No, sir.
Okay, so if you are using functions, let us say we have these functions f1 and f2, you generally write the algorithm in the same way as you are writing the flowchart in the Raptor. For example, you write start, write some inputs. So here you are sending the input. So what you will say is F1 of that input comma output you write. That's all. So connect it with your pencil or something to the flowchart here. And again it will start with 1, 2, 3 and some values like that. Okay. You know how to write if condition and all. For recursion also the pseudocode is very easy. You take it same like that. For example, there is F1 and there is recursion. You say in the start itself, if n is equal to 1, go to step 3. Okay, if this is if this is start 1, next 2, so we are going to step 3. So next you will write else go to step 4. Okay, you will go to step 4. Maybe you are giving out is equal to n here. In step 4, you will start it like this. You will say, okay, I will call again f1 of n minus 1 comma out something. See, of course, it indicates that it is calling itself. Okay. So this is how you can write an algorithm or a pseudocode. It's not algorithm. I say it's a pseudocode for recursion. And don't mix all the functions and their lines in the same flow. It should not be in the same flow like this. For main a flow, for f1 function a flow, for f2 function a flow should be written. The pseudocode should always be resembling your flowchart. So that is very important here in this concept. Okay, so I get some messages, just I want to see. Okay, right. So I think Channakeso has posted previous recordings in YouTube channel wherever he is uploading. Okay, right. Is our thing is recording? Sometimes it's not recording. Okay.
Yes, sir, it's
It's
recording.
recording.
Recording, sir.
So I hope you should be understanding how to write the pseudocode for the functions. So when you're writing the record, please prefer the pseudocode different for different functions and try to connect them with some pencil or so because you know how to connect it. Okay. So this is how you will do it. Anyway, Raptor helps you in doing all those things. Once you write your flowchart in Raptor, you can take a screenshot and put it down there. So it's your turn to practice with different numbers, practice them and try to understand how sorting technique is done. And the same way you go for the binary search also. So for binary search also, you take few numbers like, either in the descending order or ascending order, but based on that, you should change it. For example, I have 1, 3, 15, 100, 199, 200, like this. It's in an ascending order. So your condition might be changing, right? Because if you take the division of this 1 2 3 4 5 6, so you might be saying index 1 plus what is the last index, that is 6 by 2, that is 7 by 2, you will get 3 something. So you will divide at 1 2 3. Okay, so 1 3 15 and 100 199 200. This is how you are dividing every time while you are recursing through it. And we need to now say that if there is any value that you want to find, maybe 100, what you are checking is if 100 is less than or equal to the left array. This is left array, right? This is right array after dividing. But if you have a descending order, so for example, if this is the same thing but in reverse order, 200, 199, 100, 15, 3 and 1. If this is in the descending order, I think this might change. Okay, this might change. You should be saying that greater than or equal to 100 something. Okay, right? So because you are just dividing this 1531 as 1, 200, 199 and 100. So it should be either equal to, or it should be a number that is greater than this 100. That's how you are doing it. So you will only change the conditions. So please try to go to the concept. Again, you try with different aspects. One is with ascending order and one is with descending order. The flow will be same as how we have discussed, but you only change the conditions. Please change the conditions and look into that and practice it with different numbers. If you practice 4 or 5 times, that's enough that you know how this binary search algorithm is working, and you also understand how the Raptor tool is working. If you are not still confident, every time you delete your file, what you have done, please open a new one and try to write it on your own. This is how you need to practice it. Okay, so you start practicing it from the scratch. Every time you build it from the scratch, for that what you need to do, first work out on paper on how I have done to you. So earlier while explaining how binary search works, I have done some workout on paper, right? After that I tried to convert it into a pseudocode and then flowchart. So next you need to write your pseudocode and then flowchart. Spend some time so that your brain will get acquainted with these concepts. See, I used to always tell to the people, I don't know whether I have told you. Have you remembered that in Enadu Sunday you will have some mathematical puzzles? I don't know now it is coming or not. I'm not getting that paper now. But
Sudoku we will get, sir.
into the
Sudoku.
yeah, Sudoku or something, some puzzle, some mathematical puzzles we used to have like Sunday for children. Something, some page will be there. Okay, so
Yes, sir. It will be so.
my mother used to give my mother used to solve all the problems every day. She used to do she's very clever in doing those puzzles and mathematics. She is interested in mathematics, but I was not really. So the thing I have observed is here, earlier when she was giving me the puzzles and says that okay, I have solved it in 5 minutes, can you solve it? I used to take the whole day because I was not really interested. Maybe I took around 24 hours, and after that I will come with some solution which is always wrong. So okay, I was depressed and I thought that okay, I cannot solve any mathematical puzzle. And when I started solving these competitive programs, right, in hacker or hacker rank 6 years back or something, 7 years back, I started to solve these hackathons and all. So my brain was acquainted with solving the puzzles. So it was ready, it was trained. Why the military people are being trained before they go to war? They cannot be given directly a gun and say that you enter into the battlefield. Everybody will die at the same time. So why we train them? Because their brain will inculcate the idea of what to do in some situations. Okay. So when I'm doing these hackathons, and after that, every Sunday, she was continuing to give me those problems. Earlier, I did not solve it. After I'm trying to solve these problems, my brain was actively working on mathematical problems, and it was also having a lot of practice on how to solve those problems with some solutions. Immediately, it is getting a solution. So after that, every Sunday when she was giving, I have solved many times and within less amount of time. She was surprised and asked me how you could solve it when you are not doing earlier. I had only one answer after some analysis. Okay, I have given my brain a practice of something. So practice should be self-practice. If you don't do self-practice, if you don't spend at least 1 hour or 1.5 hours a day on programming, your brain will never work on programming. Your brain always thinks I cannot do it. I'm weak at programming. I'm poor at programming. It's all finished. So help your brain to understand what you want to do, and it's more powerful. I always say a brain is equal to 7 million processors working in parallel. See, in your computer there is one CPU which has 8 core or 4 core or 2 core or something, right? Only one CPU. But now you have 7 million processors. That means 7 million CPUs with you in your brain. That's what the research says. But now how many CPUs we are using? Not even one, I think, most of the time. Because we enjoy the products that are invented by the people who just used maybe 10 CPUs in their lifetime. Okay, like Einstein or something. See, even I heard that Einstein used only 1 or 2% of his brain and he could get something. Not only Einstein, there are many sages in India also who have discovered many things in the ancient, ages. When you talk about the sage Charaka or something like Aryabhatta, they have used their brain. They have come out with some solutions, and now we are just enjoying it. That's all. See how many times, how much of time they would have taken to invent 0 to 1, 0 to, sorry, 9 number system, right? So this is how you need to apply your brain to solve some problems. Okay, every solution, every product that we are enjoying now is coming up from your own human brain. How it is coming? Because they had practice. Practice yourself, don't look for others to give you practice. So in this case I already told you that, should I give you some practice like, amma please do for these numbers 1 2 6 5 4, do for these numbers 10 9 6 1 2. See, these numbers can be even written by you, right? So if you have the time to practice for 1.5 hour, take few problems on your own, your brain will work to generate these numbers, and try to write down the algorithms and get the pseudocode. Okay, right. So this is all about I want to tell you regarding the previous problems, and today I want to go to some new concept called 2D array. So I will just explain you what is 1D again, and we will go to 2D array. So if you go to 1D array, this is called one dimensional. One dimensional. So let us take why it is called one dimensional. So if you have an array, I told you that an array is a contiguous memory allocation. That means continuous memory allocation. If you have an array A, what is the difference between a normal variable and an array is that an array holds a series of values in it, and a normal variable will hold only one value in it. So you see how many boxes are there here and how many boxes are there here. So this is a normal variable. This is an array. So, and this array having the indexes 1, 2, 3, 4, and 5. So it is continuous process of allocating the values up to from start to the last. So that means you are having index 1, 2, 3, 4, 5, and you see that only in one way it is going. Only in one way it is going. So if you write a series of numbers like 1, 2, 3, 4, 5, it is in one way. That's why we call it as one dimensional. Now I will tell you one thing. I think you all have done this matrix problems like 1, 2, 3, 4, 5, 6, 7, 8, 9. What is this matrix? What is this M by N? Can you tell me?
3 by
3.
3 matrix.
3 by 3.
3.
3 by 3 is your matrix. What is this 3 by 3? So how many 1D array you are finding out? Can you tell me?
3.
3.
You have three 1D arrays that you are finding out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So to mention how many 1D arrays are there, you should be doing something like this. So imagine the same thing as this one. 1, 2, 3. The next one is 4, 5, 6. The next one is like your telephone numbers 7, 8, 9. So this is 1, this is 2, this is 3. So there are three 1D arrays. This is the first 1D array, this is second 1D array, this is third 1D array. Okay. Now, if you tell me what are the indexes of 1 to 3, can you tell me what are the indexes of 1 to 3?
1, 2, 3.
1, 2, 3 are the index. Okay. These are the index of 1, 2, 3. What are the index of 4, 5, 6?
4, 5, 6.
4, 5.
1, 2, 3.
1,
1 to
2,
3 only, sir.
3. Yes, because I said that these are individual 1D arrays. If there are individual 3 1D arrays, if you consider them as individual 3 1D arrays, in this 1D array only 3 numbers are there, 1, 2, 3. In this 1D array only 3 numbers are there. Okay, so this is 1, 2, 3. Again, in this also, in this 1D array, which is a third 1D array, only 3 numbers are there. It's not a continuation, right? So here also you will have
1 to 3.
right? So you will have 1, 2, 3. Now, if I ask you to get a value 6, if I ask you, please get a value 6. So I want to ask you what you want to fill in such a way that I am writing like this. If this is if this is indicated by m and this is indicated by n, okay? So m and n. So tell me, how do you get this value 6? Can anybody guess?
2, 3.
M2
and 3.
M2, yeah. M2 and 3.
Yes, m will be 2,
2 and 3.
n will
M
be.
will be 3.
The reason is, you see here, this is m, right? This is m1, m2, and m3, and this is n1, n2, n3, n1, n2, n3. Okay, so now you can clearly understand how you get, and even you can understand how you can fill in it. Okay, how you can fill in it. Now just combine them into one box in such a way that you will have a common thing. Okay, now let us go to the common thing. Now, I will draw a big cube type of thing. So I have 3 1D arrays like this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is indicated by m. So 1, this is 2, this is 3, and this is indicated by n. This is index 1, index 2, index 3. So don't think that it should be m1, m2, m3. I'm just making it as an identification. That's all. This is m and this is indicated by n. So just rub it out like this. So I think you will now understand that simply you consider them as rows and these things are columns. Okay, I'm just clubbing them together. So now also, if I ask you how you can get 5 number, can you tell me this is m and this is n? Can you tell me how you get the 5 number?
2,
2
2.
and
M2
3.
M2.
Yes, m should be, because this is m.
M and this is N.
So m should be, because it is
2.
2, second 1D array. So this is 2, and n should be,
And
column is again 2. So I think now it's very easy for you to understand how you can give in a array. So for example, if I want to fill these things, can you tell me what are the conditions I can write so that I can fill it out? So for that, I will discuss with you some things. Again, I will draw a cube like this. So first we are talking about input. How do you give the input to the numbers? Okay. Now, when I talk about this, first I want to fill this row. I want to fill this row. Okay. Okay. I'm sorry. I will just rub it out. Okay, so I want to just fill this row. Next, I want to fill this row. Next, I want to fill this. Okay, so first to fill it, how do I do it generally is like this. So what I will do, I will start with a of 1, and then I will say, you will start with a of 1, 1 is equal to 1. Okay, so maybe this is the input I am taking. This is the input. Next, I will say a of 1, 2 is equal to 2. A of 1, 3 is equal to 3. Next, a of 2, 1 is equal to 4. That's what, right? 2, 1. So this is 2, 1. So combination of 2, 1 is 4. Okay. So I hope you are understanding the combination of 2, 1 is 4. That's why I'm writing 2, 1. Next, A of 2, 2 is equal to 5. Next, A of 2, 3 is equal to 6. The same way, A of 3, 1 is equal to 7. You can observe why I'm writing 3, 1 in that this thing. A of 3, 2 is equal to 8. A of 3, 3 is equal to 9. So every time I'm trying to give the input so that it should happen. Now, have you observed that in this particular one, if m stays at 1, n will be going to 1, 2, and 3, right? Observe this. If m stays at 1, let me write here. So m, and this is n. This is also m, n, m, n. So here I want to talk like m is equal to 1, n will be 1, 2, 3. Here also, if m is equal to 2, n will start with 1, 2, and end at 3. Here also, if m is equal to 3, n will start with 1, 2, and end at 3. Right? So, now clearly observe that if m is 1, n will be 1, 2, 3. Again, if m is 2, n will be 1, 2, 3. If m is 3, n will be 1, 2, 3. Then what you have observed and what concept you want to deal with. I hope here also you need loops. But what type of loop you need?
Sir, we'll need 2 loops, sir.
2 loops.
Okay, you need two
Sir,
loops.
we can either use loops or recursion, sir.
First go for loops. Okay, then you can try for recursion. Okay, so first I prefer everybody to use loops. So for example, you write it on paper first, then you will understand. Okay, first work out on paper so that you will understand how I am giving it. So somebody said like two loops, right? Two loops. Are they individual loops or nested loops?
Nested
Nested
Head loops.
nested loops.
Be nested loops.
Nested.
Because when I told you like m is 1 and n will be like this, so I think a loop should be for m, right? So a loop should come for m, and in that a loop for n.
N.
Okay, so m will be initially 1. Sorry, it should be assigned with 1, and so m will be initially assigned with 1, and your condition should be, for condition I am representing with question mark. Okay, for condition it should be m greater than 3. Okay, and here n will be every time assigned with 1, and the condition should be n greater than 3. So for 1 m, n will loop for 3 times. Okay, so like that, every time if m repeats for 3 times, how many times the n might repeat is like n repeats 3 times. Okay, and it repeats for m's 3 times. That means n will be encountered for 9 times. I hope you are understanding. That's why I said if m is 1, n will be 1, 2,
1, 2.
3 times it is repeating. If m is equal to 2, n will be repeating 1, 2, 3. This is also 3 times. If m is equal to 3, n will be 1, 2, 3. This is also 3 times. Total 9 times. And this is 3 times. Okay. So this is called a nested loop. I think earlier, while you are giving an array, you are just giving a of 1 is equal to the input, a of 2 is equal to the input, right? Only m is required for that while you are giving the array, right? Not m, it should be n. Okay, because it's only one 1D array, you are only giving 1, 2, 3 indexes like n. Now you need to give the number of indexes, the number of 1D arrays also. So for that, you need to give m and n. Okay, so earlier you have written like a of n is equal to n, the input that you are taking, the dynamic input. Now your task is to write a of m comma n is equal to how much? What is that? So this is also input. So if possible, try to do it. Then I will show you the demo. Try to work out on paper and try to put this flowchart in Raptor. Let us see how many can do, and let us explain after that. Now your task starts now. Take 5 minutes or 10 minutes of time to do it. Input it and print it.
Hello, sir.
Yeah, one important thing I forgot to say in Raptor, not like programming, you will do it like a of m n. In programming, you can do it like this, but the problem in Raptor is you need to write it like this: m comma n. I forget to
Yes,
mention.
that was what I was about to ask.
Yes, yes.
Sir, we should print a matrix, sir, in this thing, Raptor.
Don't think it like a matrix. I want to ask you to print it like this. So if you give 1, 1, you take 1 as input, 1, 2, you take 2 as input. And while printing, if you give the same numbers like 1, comma 1, 1, comma 2, it should print what is in that particular input. So the output should be what is in that particular row and column. Did you
Okay.
understand? Okay. So we will print it like matrix when you come to coding. That's very easy to print it there. But now you just keep it like this in your mind, work it out on paper, and check out where you are inserting your input and how you can retrieve that as output. I have just told the matrix example because you will understand why you need 2D arrays.
Okay, sir.
Sir, can you please show that slide where you wrote the conditions?
Okay. Is this what?
Yes, yes.
Okay.
Thank you, sir.
Sir, I got it. I completed.
Okay, fine. Will you share the screen then?
Yes, sir.
Hmm. I'll stop sharing it. Okay.
Disabled, sir.
Yeah, now it is enabled. You can do it.
Alert from.
Okay, so you have given something like R. So M is greater than R and N is greater than C. Okay, right. So get M comma N. Fine. So every time N will be incremented, next M will be incremented. So before you go to the next N, you are saying that N should be 1. Okay. Fine. So you are taking as input. Okay. So can you run the program?
Yes, sir. 3 by 3, sir.
Okay. So R is equal to 3, C is equal to 3.
Array 1 to 3, I should give like that one, sir.
Okay. 1, 2, 3, 4, 5, 8, 9.
Which one we want?
So I want something like 2, 3, 2, 3. So second row, third column. Okay, 6. Fine. So I think you can also write another the same type of loop to output all the numbers based on 1, 1, 1, 2, 1, 3 like that.
Okay.
That's easy anyway. If you can get this, it is very easy for that also.
Yes,
Okay.
sir.
So this is how you can do it. You can look into what he has done, like A of M comma N. Both rows and columns he has given. M will indicate the row, that means which 1D array it is, and N will indicate the column, that means what index of that 1D array. Okay, so that's why I have explained you like with the division, and then I have clubbed them together as one single row. Okay, and column. So
Sir,
yes.
sir, when we write A of M comma N, then how could we give the input? Like, what should we give?
Yes, every time if m is 1, so it should be like a of 1 comma 1, a of 1 comma 2, a of 1 comma 3. They will increase, right? They will increment, right? Then will be incremented, then will be incremented. So at that time it asks you what is the number that you want to give it a of 1 comma 1. Next time what is the number that you want to give it a of 1 comma 2. Like that
Sir,
it will
Acha, M and N, it will take values on its own because we wrote increment n to n plus.
right. So initially he said that m is equal to something like 1 and n is equal to 1, right? Can you go, Rohan?
Yes, sir.
Yeah, you see that after start he has given like m is equal to 1 and n is equal to 1. He also is asking
Alert from.
how many rows you want and how many columns you want with R and C. For example, he has given the rows as 3. That means 3 1D arrays he is telling. And he has given the columns as 3. That means each 1D will have 3 indexes. That means you can fit 3 numbers in each 1D array, right?
Yes, sir.
C is columns and R is rows. Now what he is giving, we said that M indicates the number of 1D arrays. That means the number of rows. So for that, what condition he has given? M is greater than R. Okay, the condition he has given is M is greater than R. That means M starts at 1 and it ends at 3. It should not be greater than 3. And after that, inside that, he has given a nested loop. In that nested loop, n will start with 1 every time and ends at 3. That's why he has given n greater than c, because c is 3. If n greater than c, it will come out. then what he is doing is incrementing m. After n is completely done, again he is incrementing the row. He is going to the next row. That's why he is saying m is equal to m plus 1. Okay. Next he is starting with again n is equal to 1, like that. Okay. You can give n is equal to 1 once you come inside, or even like that. So instead of n is equal to 1 there at the end, you can also give in the nested loop. So before n greater than c, you can give n is equal to 1. But the problem is every time n will become 1. That's why he has given it like this. Did you understand?
Yes, sir.
Hmm.
Yes,
So
thank you.
naturally, m and n values might change every time. Your task is only to give the input at that rows and column.
Okay. Sir.
Hmm.
Thank
Sir,
you.
even I completed. Sir.
Who is this?
Girish, sir.
Giri. Okay, good, good.
I'll stop sharing, sir.
Yeah, you can stop sharing. So it's very easy for giving an input to 2D array and taking output from 2D array. Okay. So in the next class, I will explain you in deep how it works in terms of addresses, because now you understand this. I also want the people who are interested to learn in deep, I will explain with that addresses. So that's why this time I have told you with easiness how you understand a 2D array. Okay. So in the next class, I will explain you how it works in terms of memory, so that you already had an idea about 2D array, so there will be no confusion. Earlier mistake is I have started with memory and all. You did not understand the array, so I would have told you simply what is 1D array and how to access it, and then I would have gone to addresses. So this time I am planning for that. So now all of you understand what is 2D array, right? Yes.
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So easy for giving input and easy for taking the output. And most of the time we use this 2D array for image processing generally, because I already told you that if you consider a screen as a 2D array, the number of pixels, if you go towards a TV, you can see small check boxes, right? Small check boxes, they are called pixels, as I told you. And in each pixel, a color number will be there. So imagine the entire screen of your TV as matrix. Each checkbox is having a number indicating its color. Okay. When all that matrix is filled, you will see a screen at one point of time. Okay. So you will have most of the things for your knowledge. I'm just telling one thing is like this. Okay. So this is one frame in a screen. Okay, have you seen that in movies you will have some frames like 24 frames or something, right, at a time completely. So each frame is a matrix actually, and this holds a color number. So if you go to the TV, you will find the TV like this, yes, and this screen will disappear and a new screen will come. So it is the next screen waiting for to come, and also you will have, this is called actually
It's 10
a
o'clock.
n-dimensional array, right? So we are only working with this particular one, only one 2D array we are working. But when you consider the real world in cinemas and all, you will have each frame considered as one 2D array. So this is one 2D array, this is one 2D array, this is one 2D array. This also we will do it when we go to programming. Okay. So generally the main application of this 2D arrays is in image processing. That's what I want to say for this. Okay, right. It's over and let us leave the class. Bye bye, everybody. We will meet in the next class.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.